Today, on How It's Made, professional cookware, luxury inlaid boxes, high-efficiency water heaters, and scooters. A quality pot and pan has the ability to heat uniformly throughout so that food cooks evenly. Copper is by far the best heat conductor, but copper cookware is very expensive. Aluminum conducts heat well but isn't durable, so many cooks use stainless steel cookware that contains aluminum. This high-end line of stainless steel cookware has an aluminum core running throughout. Production begins with 2 stainless steel sheets. Using a spot welder, workers tack them together along one side. Then they lay the connected sheets onto an assembly fixture. A vacuum arm pulls up the top sheet, and they insert an aluminum sheet in between. This metal sandwich goes onto a conveyor that takes it on a 10-minute ride through an oven. The heat, 700 degrees Fahrenheit, softens the metal. This preps them for the bonding and shaping operations to come. From the oven, the metals enter the first mill, which uses electric current to heat and bond the 3 layers into one. Now it's into a second rolling mill. This one strengthens the bond. That steam you see is the water-soluble lubricant evaporating against the hot metal. Now the bonded metal travels to a second oven for reheating. This further strengthens the bond. From there, it's into a 110-ton press. It forces down a die to cut out the starting shape of the piece of cookware they're making. They clean off any debris from the metal cutting. Even a minute shard getting under the press would damage the metal. Now the disc goes into a 220-ton press containing a forming tool, which forms it into the shape of a 10-inch frying pan. A sheet of paper between each shaped pan prevents scratches. They install different forming tools on the press to produce different types of cookware, from saucepans to stock pots. Now that they've formed the shape, they need to do some refining. This trimming press first removes excess metal around the perimeter. Next comes what they call edge conditioning. The perimeter trimming left the rim rough, so now they smooth it by running it against a cutter at high speed. The next stop is a polishing machine with an abrasive belt. The pan's interior surface rotates at high speed against the belt. The result is a high gloss finish. Now for the exterior. The pans go onto a rotary buffer. Each pan runs against 10 progressively finer buffing wheels. By the end of the circuit, the stainless steel has a mirror finish. It's time to get a handle on this cookware. First, they use a press that's essentially an industrial-strength hole puncher. It applies nearly 20 tons of force to perforate the metal. Workers position rivets in the holes, then use another press to squeeze them flat. As the rivets spread outward, they secure the handle firmly in place. This company's top-of-the-line stainless steel cookware contains a copper core within the aluminum core, a structure designed specifically for induction cooking, the latest culinary technology. A thin cut along the perimeter exposes the copper within, giving this high-end cookware a signature look. After all, performance and style are everything in an industry where the competition's always heating up. For centuries, people have stored their possessions in special boxes, jewelry chests, watch cases, music boxes. Although designed for storage, they're often as beautiful and as treasured as the goods they hold. Truly ornate, handcrafted works of art in their own right. These wooden boxes are handcrafted and decorated with beautiful wooden inlay designs. To build the box structure, the carpenter uses linden, a soft wood that's ideal for carving. He begins by cutting slots in each end of the 4 sides. Then he glues wooden inserts called biscuits into one side of each piece, leaving the slot on the other side empty. Then he assembles the sides by fitting the biscuits of each side into the empty slot of the connecting piece. After clamping everything firmly together, he checks the size by tracing a template of the final shape. Once the glue is dry, this computer-guided machine cuts the sides to that shape. The next step will be to veneer the sides with the decorative wood, such as olive, rosewood, redwood, or California burr walnut. For aesthetics, workers tape 4 identical sheets together so that the grain of the wood appears in mirror image. The carpenter then applies a coat of glue onto the sides of the box and presses on a piece of veneer. They've embellished this one with some inlay work beforehand. He presses the veneer flat to force out any trapped air. This design calls for a black strip of bolivar wood to ornament each corner. To make the box cover, the carpenter uses a machine called a pantograph. He moves the head in the middle over a model of the cover. This simultaneously moves routers on each side to shape a piece of wood to the same form. Meanwhile, the inlayer lays a drawing of the cover's decorative design on a stack of wood boards and cuts out inlay pieces for several covers at once. To color the edges of select pieces, the inlayer burns them in hot sand. Some types of wood turn brown, others green. After hand-cutting the design outline in a veneer sheet, the inlayer uses tweezers to position the pieces of inlay one by one. A sheet of adhesive paper underneath holds the pieces in place for now. Once the design is complete, the carpenter fills the crevices around the pieces with plaster tinted to blend in. A final layer of plaster goes over the entire design to hold all the pieces in place permanently. Once the plaster hardens, he covers the entire inlaid sheet in glue, further securing the inlaid pieces. Now he flips it over, then peels away the adhesive paper, and voila! He glues the inlaid sheet to the box cover. Pressing it down firmly is a delicate process when the cover's curved like this one. One wrong move and crack. After lacquering the edge of the cover, workers apply 4 coats of high-gloss varnish to protect the wood. Finally, they screw on the box bottom, mount the cover to the box with hinges, install any other hardware such as keyholes, and if it's a music box, install the musical movement. Conventional gas water heaters are only about 75% thermally efficient, but high-efficiency water heaters are up to 96% thermally efficient, meaning almost all the heat they generate gets transferred to the water. It's the unique heat exchanger that makes these water heaters so energy efficient. The heat exchanger resides in the center of the unit. It's made of steel pipe that goes through a process called mandrel bending. Mandrel bending prevents the 12-yard-long pipe from kinking as it turns into the shape of a coil. A welder fuses steel rods to the sides of the coil, making the flexible heat exchanger suitably ridged. Next, a machine pumps a ceramic enamel through the pipe from the bottom up to ensure full coverage. This coating protects the interior of the pipe against corrosion. It takes about 6 minutes to fully coat the inside of the pipe and drain the remaining liquid. It takes about 15 minutes inside a furnace for the coating to cure and become rock hard. Now it's time to seal the heat exchanger inside an inner tank. They first set it down on a base, then cover it with the steel enclosure. It's this inner tank that holds the hot water. The tank then goes into a vertical press that pushes it down onto the base. A computerized arc welding machine welds the tank together. A technician then pressurizes the tank with air, and using water, he checks for leaks until he's satisfied there are none. He then pumps ceramic enamel into the tank, and a tumble coating machine shakes up the corrosion-resistant enamel, fully coating the inside of the tank as well as the outside of the heat exchanger. A technician then inserts cold water inlet tubes into each tank. He also inserts aluminum anode rods to help protect the inside of the unit by absorbing corrosive elements in the water before they can attack the steel tank. After attaching all the plumber's fittings, he installs a second anode rod that gives the tanks double corrosion protection. Now they put on what's called a rolling foam stop that helps them fit a painted jacket over the shell and maintain it in place. Here they attach the gas valve that is used to light the burner. A painted cover then goes on the top of the jacket. They connect a blower to the tank. The blower is what expels the burner's spent gases to the outside air. The next step is to hook up a burner to the gas valve. This burner is what heats the air that goes through the heat exchanger, which in turn transfers its heat to the water. A technician now fills the cavity between the inner shell and outer jacket with high-density expanding foam. This foam insulation is about 2 inches thick and goes all around the circumference of the tank to prevent heat loss. The unit then gets a cosmetic cover that conceals the blower. Finally, a technician hooks up and tests each unit. He follows strict quality control standards, which guarantee that the burner and all the fittings and connections are working properly. Only then is the unit ready for shipping. High-efficiency water heaters can deliver all the hot water you need and save you money while they're at it. The motor scooter, as we know it, hit the streets just after World War II. Europe was rebuilding its devastated infrastructure, and the scooter offered affordable transportation at this critical time. So in a small way, it helped put the post-war economy on the road to recovery. Many decades after it was first introduced, the scooter is still big on the streets, and the uncertain cost of fuel is one reason why. Production begins with the step-through chassis. It's often built on a tubular frame, but at this factory, they have a unique approach. Robots join 3 pieces of molded steel together by executing hundreds of precision welds. This transforms the 3 molded pieces into one solid chassis. After rust-proofing and priming, the chassis gets a paint job and a clear protective veneer. They cure the finish by baking it on. Then they polish away any imperfections. The chassis moves down the line where a technician installs its radiator system. The next assembler clamps the radiator's wiring and hoses to the vehicle framework. Some plastic edging helps define the lines of the scooter. This model receives a 4-stroke 150cc engine, which will make this scooter a bit more peppy than some. It also has an automatic transmission. Once the rear wheel has been installed, the worker hoists the engine over to the chassis. He guides it into place just behind the passenger seat and then bolts it to the steel framework. Next up is the steering column with the front brakes and wheel hub already attached. The technician assembles it to a front fender. Then inserts the steering column in its slot at the front of the scooter body. Securing it is a delicate business. He tightens this special tool to gently squeeze the assembly together. This technique prevents damage to the components. The handlebar is loosely screwed into place for now, but will be properly tightened down later. This scooter's front wheel has a 12-inch rim. That's quite a bit bigger than those on early scooters. The bigger wheels add stability and allow this scooter to reach a higher speed than its forerunners. To illuminate the road ahead, this two-wheeler will need a headlight. It mounts onto the handlebar. A technician then puts this scooter to the test. She checks the headlight and all the signal lights. She engages the motor and throttles up to check both wheels and the speed gauges. Once it gets the OK, a worker installs the cover on the horn and then accessorizes the scooter with pieces of trim. And now, they install the scooter saddle on a hinge over a storage compartment. Another buff and polish makes this machine gleam. The worker then installs pop-out footrests for the passenger. After one last shine, it's over to the quality inspector. That's the lady in yellow. She scrutinizes the vehicle from all angles. And when she gives it the green light, this scooter is ready to merge with traffic. Life on the street can be tough, but this design has had a lot of road testing over the years, and that's what makes the motor scooter a classic.